The question of the day is, if a train station is where a train stops, and a bus station is where a bus stops, what is a workstation? Huh? Yeah, maybe something all the supervisors should consider. All right, well, I don't create the jokes, I just tell them. I take no accountability. Welcome to episode 4. I know I called episode 3 episode 4 at the beginning because I had been away from the project for a little bit and forgot where I was, but this is the true episode 4. And here today we are going to actually create the dashboard for our work order data. What we did in the last episode was we created some elements in these two tabs that will help drive our stats on our stats page. Let's get to it, shall we? We're going to create a sheet here and we're going to call this stats. This is going to be our dashboard. Put that here. I covered this in a little bit in episode 3, where I talked about hiding some columns and rows in tabs. When I am creating a dynamic spreadsheet, that's one of the things I do is I hide some columns and rows from the user, not so that the user, we're pulling something over in the user or we don't want them to actually see what's going on, but because it's not going to really add any value to the dashboard, for example, here that we're going to create, it's just going to clutter up the screen. And so we want to be able to hide them. But we put them in columns and rows that start before the actual presentation of the data that we want to see, so that we don't end up, as often as done, putting these items way off to the right off the screen or way down below off the screen, which oftentimes ends up in those columns or rows being deleted by somebody who decides, I want to delete all of this stuff or delete these additional rows or whatever the case may be, or overwriting them, not understanding what the values in those rows and columns that are off the screen mean. So by hiding some rows and columns at the beginning of the spreadsheet, we are reducing the chance that somebody's going to mess with the stuff that we set up to drive the dynamics of the spreadsheet. The way I like to think of it is that, so for example, the dashboard that we're going to create is our stage. And these rows and columns that we're hiding and the things that we put in them are our props to the scenes on the stage. And just as whenever you go and you see a play and you see the stage, you don't necessarily see the props that are in the background that move the scenery that's on the stage. So maybe the scenery recalls, for this particular act in the play, recalls for some background scenery. Some mountain scenery. And so there will be some mountains, cardboard mountains, wooden mountains, whatever, background scenery rolled onto the stage, so that's what the audience sees. But you don't see all the levees and the rollers and etc. that are in place to roll those scenes on and off the stage. And that's kind of the way I see these items that we set up here in these hidden rows and columns. It's kind of that prop that drives the scenery in the sheet that in the part of the sheet that we want to see. It's probably not a really great explanation, but that's the way I like to think of it. And once you kind of see what's going on, maybe you can come up with a better description or way to describe it. And if so, put that in the comments. I normally do A through J as my columns. I set those to column width of 3. And then I do rows 1 through 10. And I set those to a row height of 8. No, I don't. I set those to a row height of 12. For this Dashboard, we're going to set all of the font to Arial. However, in our hidden rows and columns, we're going to set our font to 8. I selected that again for the rows so that these over here that were not in the column I selected would also be 8. Having set that up, now what we're going to do is we're going to start our dashboard here in cell K11. Our first item is going to be location label. And here, this is going to be, I'm just going to change this to, let's see, what location has, I think maybe Alvin. That's data to work with here. And then this is going to equal that value. And then as we change that value with our slicer, it will change here. And we're going to call this R stats selected location. It's going to be the range name there. Now for our first block of information, we're going to want 4 columns. And this is going to be days aged. So we're going to merge that across those 4 columns. Here, we're going to say from to number of work orders and percent of total. We want to wrap that text. We want to make a column width of 9.43. How do I know that? I just copied it from the dashboard I've set up. However, if I was creating this from scratch, I would make the column widths based upon whatever the need was as I went along creating this. But since I already know what they are, I'm just to make it quick and easy, and so you're not having to watch me set different, try to figure out what's the best column width to go with. I just am copying these values from the previous dashboard. This is going to be, we're going to center these. Then in the from, we're just going to say 1, 2, 6, 2. I'm just setting up the bins or the brackets, whatever you want to call them. In stats, they call them bins. That we're going to break our number of work orders into, or based on the age that we're selecting here. Now I just randomly chose 1 to 5, 6 to 10, etc. as my bins, but you could choose whatever you want. That's just what I did. We're going to center these. Now, it's important to note that these are actually numbers. I included the words in this column because I'm going to use this to drive my next formula. What we're going to enter in here is frequency. That's the function we're going to use. And as you can see here, the frequency function calculates how often values occur within a range of values and then returns a vertical array of numbers. For example, use frequency to count the number of test scores that fall within ranges of scores. Because frequency returns an array, it must be entered as an array formula. And then you have this example here where they have these scores and their bins are 70, 79, 89. And so you can see the output down here is number of scores less than or equal to 70 was 1. Number of scores in the bin 71 to 79 were 2, etc. So we're going to use the frequency function here. So equals frequency. The data array is R selected days aged dot days aged range. And it's going to be based upon this value here. And then notice it created this spill here where it's returning the values based upon what we have here. The little blue shade of the line indicates that this is a spill. So when I click here, you'll see this is grayed out because it's a spill. That's not actually the value that has been typed in there. So I can't change that. I can't come in here and alter this. See, when I click into here, it shows that there's nothing there. So the total here is 30. And when we come back here, we can see that the count is 30. And so we can see that this formula is working for us. Now notice this leftover. Basically, by indicating that these are the buckets that we want to, or the bins that we want to count, there are those that fall outside of these bins. And for those that fall outside of these bins, then it includes an additional row here of how many of the values fall outside of these bins that we've indicated. So here we're going to type in the label total, and we're going to do an equal sum. And then here we're going to do an equal sum as well. And we're going to add that. Since this is a percentage of total, we will say equals this value divided by this value, which we're going to lock. And then we're just going to drag this down. Now we're going to make these a percentage format with 2 decimals. This is going to be our first little blocked off section. And there we have our first section. Now what we want to do is we want to create our first graph that goes next, that displays this information graphically. For those who can't necessarily look at these numbers and see the picture in their head of what it looks like, so we're going to put in a graphical display of this information to make that easier for people who rather prefer looking at graphs of data as opposed to just looking at raw data. Insert. We're going to select this, insert graph. We're going to format this axis so that the maximum is always 1. We're going to select data, and our axis labels are going to be this. Our chart title is going to equal this. And let's see, there is no recommended chart design that just has the black and white. So we're going to come down here and choose that. And why do I do that as opposed to color? My preference is the only time that we need to spend additional money printing things with color is if the color actually adds any value to the presentation. So if we're going to be printing things, we often prefer to have everything on that page be in black and white or grayscale, as opposed to color, because you print color and it gets to be pretty expensive. And I've seen people print a document out that has color on it that costs way more than just black and white, find an error and say, oops, here's this error, let me fix it. They fix that one error, print out 10 more copies for everybody in the room, hand them around, and then say, oops, oh, look, I found there's this typo here. Let me make that change. They make that change, print it out again, and there's flushing the money down the drain, basically. Which, hey, got a lot of money, who cares? But if you're running a business, you're not wanting to just flush money down the drain. And if you're working for the government, hopefully you're not wanting to flush money down the drain either, because that's taxpayer resources that you're using. And so I'd rather just use the grayscale or the black and white, unless there's a reason to actually use color. Now, having said that, if you're doing a sales presentation, then more than likely you're going to want to use color because you're trying to impress the person that you're making a sell to. And unless that the person that you're trying to make a sell to has the same opinion you do about printing color unnecessarily, you're going to want to use color. All right, so now we're going to do a gap width of 0, and then we're going to move this over into here. Not quite on the cell lines. So we're going to make these 8 and these 8 so they all show. Here we're going to want to say make a solid border, and that border should be black. And for our fill, let's make that a little less grayish. So again, if we print it, we're not using tons of ink. For this though, we want to use black, so it really stands out, black. Make that 11 or 10. We don't want a border on the graph itself. And here we want a solid line with the color black. Okay, so we're done with that. Now we move into here, hold down the shift key, select these, and we put a border around it that way. Now when we come into view and we take off grid lines, oh, look, you can still see a border. So it still has a border. We want no line. There you go. Now it looks like it's large enough that it fills up this entire area whenever it doesn't really. This allows us to make it look like it is fitting in with the alignment of these other sections without having to try and go in and very minutely get the graph to be right on these on the borders of these cells. Plus, the other thing is, if you get it right on the border of these cells, then you wouldn't be able to do this outline here, these borders on the cells themselves, because the graph would overlay them. And so if you have where the graph itself has a border that can be seen, again, it can start to look pretty wonky. So this is a way of making it look pretty clean. And then here we're going to want 2 columns. We're going to call this days aged. Again, and it's going to be our stats. So we're going to merge that. Stats and days aged. We're going to wrap that. We're going to make these centered. Then we're going to use our stats: min, max, mode, average. Why do we do mode and average? Because some people like to see both of those. We're going to include the standard deviation, the interquartile range, and the median absolute deviation. So for our min, we're going to say equals min, and we're going to use the range R, selected days aged range. Our max, we're going to say equals max, R, selected days aged range. Mode equals mode, R, selected days ranged. So that's why I use those range names. Makes it easy to fill out these formulas. Plus, in this case, we really need to, because we are working with that column in our pivot table, which can vary in the number of values it has in it. Average, R, selected days range. Standard deviation. So this is the total population. And this is also our selected days age ranged. Now this next formula we're going to use is the quartile function. So this returns the quartile of a data set based on percent values from 0 to 1 inclusive. Quartiles often are used in sales and survey data to divide populations into groups. For example, you can use quartile.inc to find the top 25% of incomes in a population. The syntax is quartile, array, and then your quartile. The quartile function syntax has the following arguments. Array is required, the array or cell range of numeric values for which you want the quartile range. And then quart is required, indicates which value to return. If quart equals 0, it's the minimum value. 1, first quartile, which is 25th percentile. 2 is 50th. 3 is 75th, and 4 is maximum. So just a quick explanation of this next function that we're going to use. So equals quartile, and the array is going to be R selected, days aged range, and we want the third quartile. And then we're going to subtract from that the first quartile. So R selected, which gives us 8. For the median absolute deviation, it's pretty much the same formula except for we divide the results by 2. So we can go into here and we can just do Control-C to copy that, and then Control-V to paste it. And then we come in here and we put our opening parentheses, hit the end key, do closing parentheses, so that this calculation happens first, and then we divide it by 2. And interquartile range is a measure of statistical dispersion, and your median absolute deviation is a robust measure of the variability of a sample of data. Now, if you want to know more about what the entire quartile range is telling you, or what the median absolute deviation is telling you, you can always go and look that up on the internet or in Khan Academy. I think they may have some videos there in their statistics section. But this isn't a statistics course, so we're not going to get into trying to teach all that. We're going to make this the accounting, the comma style, and then we're just going to make it so there's no decimals. And now this is that section. Okay. We're going to make sure that these are column width of 8. And this is a column width of, this is column Q, so 7.86. Column width of 8.57. Column width of 7.57. You can actually just go ahead and copy this entire thing and paste it. So we're not having to retype everything, and we're just going to change this to all. So T through W is going to be column width is 8.43. Column width of 7.57. But we should make this the same. So column width of 8.57. And then column width of 6.71. Now we need to change our formula here though. So it is referencing our bends here, but we need to change this from the selected to our all. So 467 is the count when we come over here, or is this the sum? When we come over here, the count is 467. So we know that that formula is working appropriately. Now, because we had locked this in, it's comparing it to M3021, which we don't want. We want that to be V, so we're going to change this to say V. And then we're just going to copy this down. We're going to come into here. We're going to go into chart design. We're going to select data. Our series here is going to be here. And for some reason, it reverted this back. And we want to get rid of these decimal places. So that gives us a little more visibility within the actual data there, which we also want to do over here. And now we just need to come here and change these to our all days range. Oop. Can't just start typing that in. Here are all I am instead going to do Control F. And I want to do and replace all. So I having to go in and type all that. So you can see now that changed that for all of these that were within the selected cells that I had selected. Now, what this is doing is it is giving us a comparison between the day's age data for this location compared to all. So we can kind of compare, okay, so Alvin office had 30 work orders within this year that we're looking at, the data that we're looking at, compared to 467 overall. And they had 60% of their work orders were dealt with, addressed within 1 to 5 days, whereas for all of the work orders, 50% were solved or addressed within 1 to 5 days. So we can see that their numbers here, they vary, but when it comes down to 31 plus days, they had a better percentage, only 6.67%, which is only 2 for them, compared to 13.49%. So that's the first part of our little segment there. Now we're going to put in a little section that will show us how many work orders were received in a given month during the year. And what this hopefully will tell us is there a particular month where there's more usage, more repair needs, more maintenance needs, or whatever than in other months, so that we can kind of maybe go out and see, well, what's going on in that month that is causing all of this damage or this need for work orders compared to other months. And if there's something that is causing that, then we can address it. And by the way, I also want to make these in an accounting format with 0 decimals. So it's just a little easier to spot when there's a 0 value. So we're going to say number, we'll put in this label number in month. And then July, August, September, and I think now we can, drag this over till we get to June. So we're not again having to type all that. We will make it centered. We'll center that as well. And then we're going to make all of these bold so they stand out, which, by the way, we want to make these bold so they stand out. And what we want here is we want requested compared to completed. And now we're going to use a get pivot data function. We're going to come over here and we're going to first narrow these columns so we can see everything. We're going to come over here, and from this pivot table, based on the location that has been selected, we're going to pull data for the different months. So this is requested, this is completed. So for the requested row, we're going to pull from this pivot table, and for the completed month, we're going to pull from this pivot table. And here, the get pivot data function returns visible data from a pivot table. In this example, get pivot data cells A3 returns the total cells from a pivot table. The syntax is get pivot data, your data field, the pivot table that you want to pull from, the field 1, item 1, field 2, item 2, etc. So your data field is the name of the pivot table field that contains the data you want to retrieve. This needs to be in quotes. It's required. The pivot table is a reference to any cell, range of cells, or named range of cells in a pivot table. This information is used to determine which pivot table contains the data that you want to retrieve. This also is required. Field 1, item 1, field 2, item 2. These are optional. 1 to 126 pairs of field names and item names that describe the data that you want to retrieve. The pairs can be in any order. Field names and names for items other than dates and numbers need to be enclosed in quotation marks. And so they give you an example down here. Basically, the way I look at this is it's as if you are, let's say you're going house shopping and you're on a website and they have filters, and you want to be able to look for a house that has 3 bedrooms, 1 kitchen, 4 bathrooms, a swimming pool, and you want to be able to enter those values and select only those items that have those houses that have those items that you want to filter by. Basically, that's the way I see the get pivot data function is I can, in this case, I'm selecting a value from this table based upon the location and then the month. But if this pivot table was more complicated, then I could enter more items that filter out or get exactly drilled down to, probably is better way to say that, drill down to the data that I want to get out of a more complex pivot table. The way I usually write my get pivot data functions is that I start it and then I click on any value in the pivot table, and then I adjust the arguments accordingly. So I'm going to show you that. I just say equals, and then I just come over here and I click on that, and it puts in this get pivot data function. We want the work order ID, which, see, count of work order ID, that's this here, that's what this data is in here, it's the WOID. And I want it based upon A3, number requested completed tab A3, which is here. So it automatically says, here's a cell in the pivot table, which tells it I want the data from this pivot table. And then I want the location, because I selected, when I clicked in here, it automatically fills in that I want it location and the month. So location, Abilene office, request month description, JUL for July. That's fine if I was ever only going to be looking at the Abilene office and the month of July, but I want those to be variable because I want the location to change based upon the selection here, and I want the month to change based upon where I am here. And so I just come in here and I edit this to say my location is R stats selection located, or selected location. And then I come into here and I say I want that to be L23, but I want to lock the row but not the column. So I hit F4 once, it locks both, and then I hit F4 again and it locks just the row. And now you can see for the Alvin office, here we are, the month of July is just 1. Now that I've done that, and that's why I just click on anywhere in the pivot table to get my get pivot data function, because then it saves me having to type all this out or fill in all this other information, and I only need to change that selection information that I want to make variable. Now I just do that, and so you can see that that is selecting August. It's still doing the Alvin office. And so when I select all of those, you can see that there's 30 that was requested, and there's 30 here that were requested, or total for the year. And now to do the same thing, I just simply come in here to the completed. I come over here and I just click anywhere again, and I'm just going to choose this. And notice now this selected P3, which is this location here telling us pull it from this pivot table. So I don't have to be all smart and figure that out myself. I just click on there, and Excel's smart enough to fix that for me. So then I come into here for the location and I do R stats the selected location. And for the completed month description, I come into here and I hit F4 twice again because I want to lock again the row but not the column. Drag that across, and you can see the sum is 30 just like up here. Okay, brilliant. But now, looking at this, it requires me to figure out, to visually spot on my own, where the maximum, where we receive the most work orders, which month. So that data is a little noisy to go through, and okay, here's 5, and oh, there's 3 4s. So we completed the most in January, February, and March. January was when the most was requested. But I want to be able to visually display that so I don't have to try and decipher that myself. So over here, I'm going to say max, and I'm going to say equals max. And we can see that it's 5. And here we can see that it's 4. Now for this row, I want to come up in the conditional formatting, and I'm going to highlight cells that are equal to A24. And I want a custom format. And so my fill, I actually want to just be this light gray here. And now that immediately pops out. Well, maybe I want that to be a little darker. So let's edit that rule and let's do the format. Let's make that color. Now we do the same thing here, conditional formatting, highlight cell rules that are equal to here, and we want to custom format that, and our fill will be this one. And there you go. Now we just close that in, and we have that little section going on. And now immediately it shows us, without us having to decipher the noise of the data here, which months we had the most requested and which months we had the most completed. Now in my original dashboard, I did not define what this meant, what these highlights meant. Now I am guessing that I was thinking I would know what that means, and I would be presenting this data to anyone, and so therefore I could explain it on the fly, but that's not really a good method. And so what we want to do is we want to be able to define that, and we can do that here simply by coming into here and here we say we start with the apostrophe equals max. Yeah, actually let's say color equals max. Want to center that across selection. Center that across selection. Let's do one more thing. We don't need this anymore. Well, maybe we do. Don't need that anymore. So that kind of explains, okay, well, when this shows up, that is the max. Now that's all that I used these columns for, so we can go ahead and hide these now. And I didn't use the rows for anything, so we can hide those. And now we want to look at our crafts breakdown. Here we're going to want several columns. Looks like 5 columns in total. So 1, 5, we merge and center that. Selected location. And this is going to be across 2. Then we're going to come over here to reference. And we're just going to copy all these. Paste them in there. Want to sort these. Then we want our total. And we are again going to use, actually want to merge and center that across 3 there. We're going to use another get pivot data function. So we're going to say equals, come over here to graphs or craft, and click anywhere, it doesn't matter. Because again, we're going to change it. And we're going to say the craft equals here. And our location is going to be here. Then we simply drag that on down. And then we do a total. Box that in. Box that in. And then we're going to do all. So that we're comparing the selected location to all. And percent of all. We're going to center these. We're going to do another get pivot data function. And we're going to come over to crafts. And we're going to click down here on our total, our grand total for our columns. Then we're going to come up into here and we're going to make this here equal to that. We just simply drag this down. We do a auto sum. 467, see that agrees, that agrees, that agrees, that agrees. And then our percent of total is going to be equals to this divided by this. We're going to make that a percent with 2 decimals, and we're going to drag that on down all the way to here. I don't like, when it has these zeros here, I don't like the way that looks. I like to be able to see and when there's 0 values, for it to really just stand out, which is why I choose the accounting or the custom format. It's the comma style, but then which is the accounting, but then when you get rid of the decimal points, it changes it to custom. So for example, I'm going to see now change it to accounting, but when I get rid of those decimals, then it says it's a custom format. To me, that makes the data look cleaner than having a bunch of zeros there. And so I'd like that also to do that. Let me do this as a format for my percentages. So I'm going to come into here and I'm going to do a custom. And my custom is going to be this with a underscore, and then red, red, so it's going to show, if it's negative, it's going to show the value in red plus have brackets. And if it's a 0, put in a dash. So I think that looks cleaner than having all those 0 values there. I come back into here, select this, do Control C, format these cells, do custom, Control V, format cells, custom, Control V. Now, yes, if these are negative percentages, they will show up in a red font, which I just talked about earlier about not printing in color. But there's not going to be any negative percentage values on here, and so I don't have to worry about that. Otherwise, I would modify that. That's just kind of my standard format that I use for percentages, my custom one that I created. If there were possibly going to be some negative percentages on here, then I would change the red to a different value. So we box that in, and we box this in, and we box that in, and that. Now we have that section. But I want to make sure that I don't have errors in my formulas, so that my total that for crafts for the location should be the same as my total for days aged, and for all number of work order should be the same for all of my crafts. And so what I'm going to do here is I'm going to come in here and I'm going to do conditional format, highlight cells, and then I'm just going to say OK. I'm going to come in here and I'm going to manage the rule. And I'm going to say cells not equal to, and I'm going to change this to, say, M21. So if for some reason, let's force an error, then that tells me, hey, you got a problem. Got a problem. Somewhere, got a problem. So here we're going to do the same. And I just do this so that I can get the rule in there because it's easier for me to manage it this way. So not equal to. So if I take that out, oh, see, now it got an error. So that just helps with the proofing to make sure that my data that I'm pulling from these different pivot tables are actually equal. Now we want to look at work order status. And these are going to cover these columns. Selected location. That's going to cover these. So closed work orders, complete, new request, and work in progress. I like that that's not a capital. We're going to use another get pivot data function. So we're going to say equals, and we're going to come over to status, and we're going to click anywhere in here. Doesn't really matter, because then we're going to come in here and we're going to change the status to reference this description, this label here, and our location we're going to change to here. And we can see that now we have our values there. Come down here, we do a total. Auto sum that. Put that in a box, put that in a box, put that in a box. Let's do conditional formatting. Oops, I didn't mean to do that. Highlight cells equal to, yep, whatever. And then we're going to manage that and say not equal to yep. So now if I put in there, shows we got an error. This will be all, and this will be percent of all. Going to say equals, and we're going to do a get pivot. So we come over here to status, and we're actually going to select our total. We're going to change this hard reference to this dynamic reference. And we're going to drag that down. We're going to do an auto sum. And we're going to say this divided by this. We're going to come up into here, format cells. We're going to select this, Control C, cancel. And we're going to do format cells, custom, Control V, and we're just going to drag that down. Make that a bracket. I missed with my click. Make that a bracket. And make all of that, I mean, not a bracket, but a box. So we want to add our error trapping here. Not equal to and that works. Now we have this data. Of course, it's in the raw kind of data format. We can view it, eyeball it there. But let's put it in graphical representation. In my original dashboard, I used pie charts for these next two graphs. I created this a long time ago. And since then I've learned that pie graphs really are not, they really are not functional or usable. I know people like them, like the way it looks, but science shows that the human eye really and brain can't really read a pie graph in a way that it should. Now, if you label things, if you label the slices, that's easier because you can see, okay, well, yeah, 30% versus 70%. That's what those different pie sections represent. But if you don't label it, then it's a little bit harder for the brain to determine, okay, well, what percentage is that slice of the whole? Or when you got a bunch of slices, things, they don't look quite right. So I know I'm not doing a good job of explaining it, but the science is there. You can go and read about the science of graphs and the presentation of data to see why the recommendation is don't use pie charts. So I'm not going to in this case. In this case, I'm going to actually make these column charts as opposed to pie charts, which will be different than what we originally had. Our first graph is going to be the work order status. And I believe we go about right here. Center that there. All right, so now we want to select here and here. We go into insert. We're going to insert this. We want to switch the row and column because we want to be able to add a legend, and we want that legend to be along the bottom. Our title is going to be equals to that. We don't want this, and we don't want this. Change colors, we're going to change it to this. And let's see, let's add some data labels at the top. There you go. We'll see what that looks like. Okay, we're going to come in here, we're going to get it as close as we can. We're going to make this 8. Let's see, what do we do there? 10. So we're going to make this. Oh, we're going to delete that. We don't need it because we have our title up here. And then for the graph, we want no line for our border. And we come down here like this, and we select that. Now for our next graph, we're going to have to do some setup. So I'm going to go over here to reference, and I'm going to pull this over here so it's next to stats. And I'm going to create a graph items section here. And the first thing we're going to do is we're going to create a dynamic title for our next graph. So we're going to say equals r stats selected location and quotation mark space work order % of all. So that's going to drive our title. Our next value is going to be stats selected location and total, and then all total % total. So this is going to equal our all total is going to equal the all minus our selected location, and then that should equal 467, which it does. And then we're going to get the percentage of that. So this, divided by that, and this divided by this. We're going to make these %. And now our graph is going to be based on this. And our chart title, while we're here, might as well go ahead and choose that. And now we're going to cut this, Control X, and we're going to come over here and we're going to paste it. And actually, we don't want a title here. What we want is to make this looks like I forgot a value up at the top there. We're going to merge and center that, and this is going to equals that. Don't want that. We can leave these down here because it shouldn't be, hopefully anyway, shouldn't have names that are much greater than what we're going to, the graph area that we're going to use. Where are we at? Chart design, change colors. Here we go. And we're going to have the border no line. Let's add data labels. And let's get rid of these. We want it to do the same there. No need for the little lines if we're going to have our data labels there. Okay, and now we close that within our little box. Now it looks like what I forgot to do was create this section here. And this is going to be equals to here and under over all work orders. Want that to wrap. Yeah, we actually didn't want that to do that. We want this to do that. And we didn't want that. Instead, we wanted that. Let's go ahead and select all of this and say no borders. Now this is equal to this value, all days aged min minus this value. So that we can see, okay, the Alvin office is 140 days aged under the max. So that's good. So this here is telling us, without really having for us to do a visual comparison between them, we can just look here and see that overall, the work orders for the Alvin office, the days aged for all of our different stats were better for Alvin office than they were for all the sites put together. Okay, and so now I want to come into here and I'm going to say no border. Yeah, I didn't want to do that. Looks like what I did in the original was I did a thick border there and I did a thick border here. And there you go. We pretty much now have created this Dashboard. Now the only other thing we want to do is we want to add some notes for the reader. Notes IQR equals enter quartile range, a measure of statistical dispersion. It is a robust statistic having a breakdown point of 25% and is thus often preferred to the total range. And then MAD is equal to the median absolute deviation, a robust measure of variability of a sample of data. Spell check. And let's actually spell check the entire thing. Good to go. We want to make these an 8. We don't want them to be that big. Actually, let's change this to all be a merge cell. And we're going to make these a 9. We'll want to center that. And then merge, 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 merge. We want all these to be here. And then we do this. And now this looks like the dashboard that we had started out with that we said we were going to create, except that instead of pie charts, these are column charts. Now, we need to add the slicer, and we'll do that next. Before we do that, why did I put this information over in the reference to drive this graph? Well, the thing is, if we don't really, we have to calculate this data, and we don't really want to show that somewhere else in the sheet. We could hide it over here, except that whenever you hide rows or columns, it no longer is available to a graph. So if we were to put this information here in these hidden columns, then it wouldn't show up here. That's just the way it is. So we can't hide that information so that it doesn't accidentally get overwritten, or it's showing up and somebody's like, what is that about? Or it's distracting from our dashboard. So that's why we put it over here under reference. Okay, now we're going to move reference back to the end. Right click, come back to stats. Now we're going to insert a slicer. Insert slicer. And we want it to be based on location. Want to Control X and put that here. Lower that to here. Yeah, here we go. 2 columns. There you go. Okay, let's find something that has quite a bit of data. So this is interesting, right? We want data labels. Just clicking through because I'm trying to see if we have more over here. Something with more data that has like a new request or a work in progress, which I don't think there is, except for here we got something, one, that allows us to add a data label, that allows us to add, okay, there you go. That's what I was trying to find. There you go. So here we can see that the, I don't know how to say that, Anahuac, I don't know. So their performance is a little bit worse than, well, an average in your standard deviation than the other sites. And they actually set the standard for the max. You can see that there. Most of their maintenance was most of their requests. Now we have one more tab to do, and that is our instructions tab. Let's go in here and insert a tab, move it here. We're going to call this instructions. Instructions. Okay, gray tab equals data tab that drives the pivot tables. That's this here. Let's go ahead and color this gray. And we actually want to move this next to stats. Because this is what, whenever they're replacing data, this is where they're going to come in and do that work. So we want that to actually be closer to those tabs that we reference quite often. Okay, green tab equals interaction required on this tab. Let me come up here and put a period. And so that would be this one. Tab color green. Let's lighten this up a bit. So it's got the black lettering. Okay, blue tab is a calculated tab. No interaction is required as long as all pivot tables are refreshed. So we'll do this. I don't know if you can actually come in and select them all and do the tab color that way. Ken, all right. Yeah, I just learned something new. The orange tab, tab, equals analysis tabs. Use the pivot table in this tab for to conduct analysis. Yep, that one should actually be orange. Or peach, I'm not sure. In the stats tab, change the location value via the slicer. To change the data, delete all rows except for the first 2 rows in the work order summary data tab. Then paste the new data without headers into cell A2. Right? Yep, A2. We don't want that to be that long though. So let's wrap that. Age description, tab, age description tab can be used for analysis so that we know what type of work order took so long to complete. And then the analysis tab is for free form analysis. Note 1 equals to that plus 1. All right. And that should be all of our notes or all of our instructions. But let's come back into here and we need to remove the grid lines. There, now that looks better. And voila, we are done. That is an example of creating a dashboard that hopefully you were able to follow and get some ideas from. And now if we were to print this, we would basically just come into here and set our print range and then print. Oh, so that reminds me, there is one other thing. We'd have to change the orientation, landscape, and etc. But there is some other things I forgot, which was I needed to put in a header, and the header would say maintenance work order stats. And we want that to be bold. Let's make it a 12. Since everything else is Arial, we want that to be Arial as well. Okay. All right. So it shows up there. The other thing I would do, I would always do, if you're going to print something out, I mean, the idea of a dashboard is you don't need to print it out. You're looking at it, but let's say you wanted to print it out so you had some historical data. For whatever reason you wanted to create historical data, then you also want to put in this information so that you have a timestamp of when you printed it, so that if you were comparing multiple printouts, you'll have an idea of when each was printed out, so you have that comparison, as opposed to, well, which one did we print out last month, and which one did we print out this month, and which one was for last year and this year, and blah 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 blah. And so, okay, there you have it. Now we are done. Whenever I do here, we can see it has that. I would do narrow margins, and I would do fit all on one sheet. And that doesn't really matter because it's being compressed horizontally, not vertically. So it doesn't matter what we change here. It's going to not allow this to be any larger. But there you have it. Hopefully that was helpful, and I appreciate you coming along and joining me for this project. Have a great day and keep learning Excel.